I welcome you in a new class of class 10, chapter 9, circles. We were continuing from previous example numbers 5. After doing some theorem, based on those theorem, we did some numericals. Example 6 is like this. In this figure, it is there in the textbook at page number 190. You can see it is already given. The diagram is also given in the textbook. So, solution I'll start here. In the figure, this is the circle AB and CD. AB and CD. AB and CD are two chords. Okay, chords. Chords are those lines which intersect the circle at 2 points, like A and B intersect here and there, C and D intersect here and there. And after that, it says that in the question, they intersect each other at E. So when they cross each other, that point is E. Fine, that much is given. Now the question is, number 1, you have to prove that this circle, this ADE, this circle, this triangle in this circle, and this triangle, the other triangle BEC, CBE, you can say anything. These two are similar. Remember, not congruent, similar. That means their corresponding angles are equal. That you have to prove. Also, after doing that, second part also you have to find, if suppose BC is 18, DE is 6 and AE is 18, calculate the length of BE. How much will be BE? So first of all, we'll do this, and very easily the second part will be solved. Okay, I will not draw the diagram again because it is already there in the question that we will rely on, right? This question goes like this. Now, you remember there was a theorem. The theorem number I'll tell you. Angles in the same segment of a circle are equal. Okay, same segment of a circle. If there is a circle, these two angles were equal. Remember, same segment, right? These two angles. So this theorem we are going to use it here. Okay. So here, if you can see the diagram very carefully, you can understand this. Angle 1 and angle 2, they are in the same segment. 1 and 2 are in the same segment. Why? Because angles in the same segments are equal, which is already proved in the theorem. So what you write is, since angles in the same segment are equal, so this will allow me to write angle 1 equal to angle 1 equal to angle 2. What is angle 1? Angle 1 it means ABC, or you can say ADE also same. Angle 2 is CBE, or you can say EBC also. You can also say CBA also, they are same. Okay. And another thing I can find it here is that angle 3 and 4 are also in the same segment. If you look at the circle from upside this way, okay, you look downside, this and this, from these two point of view, you can see this angle and this angle, they are in the same segment. Just like 1 and 2, from the upside down, you can see 3 and 4 are also angles which are in the same segment. This is the reason. Now, in triangle ADE, why we are doing? Because we need to prove this ADE and CBE, and triangle CBE. When I am going for these two triangles, what I see is angle 1 is equal to angle 2. Why? I have already proved. Angle 3 equal to angle 4, already proved. If two angles are equal, and also if you want, you can write this angle is also equal to this angle because they are vertically opposite angles. If you want, you can write that. DEA, angle DEA, actually not required, even two of them also are enough to make that similar angle. BEC, angle BEC, this is also equal, vertically opposite angles. This is not actually required to write because 2 is enough. Okay, here we have already proved this. So you have found that angle triangle ADE is, this is a symbol of similar. Symbol of similar is this. Symbol of congruent is this one. Okay. Triangle CBE, which is proved. First part is proved, right? Now you have to go back to the previous chapter triangle, in which we already know if two triangles are similar, their corresponding parts are proportional. What does that mean? If you divide the same side in the other triangle by the previous triangle, they are going to be always equal. Let us see how. Suppose I choose AE. Let me write this triangle DE. DE is this side. Similarly, on the other side, BE will be the same type of side on the other triangle. Where I choose DE, here I have to choose BE. Similarly, on the other triangle, first triangle, second triangle. In the other triangle, I choose AE equal to divided by CE. If this happens, same. If I take, that will be equal. This is the meaning of they are being proportional. Okay, not equal, proportional. Means if it is 2 times of this, this will also be 2 times of this. If it is 3 times to each other, if this is like this, if it is 2 times, it will be 2 times like that. Okay. So what I need here, I'll see from here. DCDE, there I'll try to prove here. So why I wrote this? Corresponding sides of similar triangles are proportional. Is the meaning from the previous chapter. Okay, in the triangle chapter, this was done. Now what I'll do here is, DE value is given in the question 6. BE value is not given. We need to find. I'll write as it is. What about AE? AE is given in the question 18. Write it 18. CE. This is not given, but we are given DC. So how to write? CE I need, but is given DE. So what you will write it here is 18, the whole thing. CD is 18 minus DE. DE is 6. Okay. Why I wrote this? Because this is CD minus DE. Okay, no need to write this. Just I want to show you. CE is CD minus DE. That is why it is 18 minus 6. Okay. Now you look at here. 6 by BE equal to 18 by 12. Now we cross multiply and quickly find what is the final answer. Calculate the length of BE, which is the only unknown. So cross multiplying will give you the answer. BE into 18. You can cancel also. 18 BE equal to 12 into 6. By 18. 6, 3 is 18, 3 4s are 12. So remaining it is 4 centimeter. These are the two answers. Okay, part 1 and part 2. That is all. Thank you.